This video is to offer you some homework hints on section 1.2.3. Starting with 168, it says, Harry had a pile of 48 pennies. He organized them into a rectangular array, basically meaning that he made a rectangle out of them, and it had 4 rows of 12 pennies in each row. All right, so you can visualize hopefully 4 rows with 12 pennies in each row, making a total of 48 pennies. All right. They want you to draw diagrams to represent at least 2 other rectangular arrays he could use. In other words, are there other rectangles that he could create with 48 pennies, where we'd end up with no leftover pennies, and it would complete a rectangle. So they want you to draw diagrams to represent that. So all you need to do is basically, put dots for representing the pennies, okay? And let's say you had decided, let's say we'd take a simpler example, maybe you had 6 pennies and you wanted to make a rectangular array. All you would need to do is something like this, all right? That's showing that we have 2 columns or 3 rows of 2, all right? So that would represent 6 pennies. So the idea is, can you do the same thing with 48 pennies representing a rectangle in a situation other than the 4 rows of 12 pennies? So they want at least 2 other ones, and then think about whether there are more than that. Then for 169, for each number of pennies, they want you to arrange them first into a rectangular array. So you're going to make a rectangular array, excuse me, and then make a different rectangular array where there's actually a leftover penny. All right. So for example, if I look at 10 pennies, I could look at a 2 by 5, I could look at a 1 by 10. All right, so either of those would work for the first complete rectangular array. But if I'm going to have a leftover penny, then the second one would be maybe a 3 by 3 with 1 penny left over. Okay, or maybe a 9 by 1 with 1 penny left over. Then on the bottom, 170, you're going to go ahead and figure out how many pennies are represented by these expressions. Keep in mind, again, when you have a number in front of parentheses without another operation sign in between, it means to multiply. Also keep in mind that you want to use order of operations, meaning that we do multiplication before we do addition. So for A, you would not do 3 plus 4 and get 7 times 5, because that would be doing the addition before multiplication. Instead, you would do the multiplication, 4 times 5 first, and then add the 3 to find the value. For 171, they want you to write at least 8 addition equations that have a sum of 10. So, you can think about simple things like just 9 plus 1, but you're also allowed to use fractions. Okay, so you could think of, a mixed number plus another mixed number to equal 10. You could think about decimals that would add up to 10. So real simple addition equations that have a sum of 10, and you do not need to write more than 8. 8 is fine. For 172, you are going to be placing a less than or greater than sign between the pairs of numbers. Again, as we've talked about before, you can compare each place value, compare the ones, compare the tenths, compare the hundredths, or another option is you can add a non-essential 0 if you wish to. Like for example, on 171, I could add a non-essential 0 behind the 7 here, so that I'm now comparing 5 and 207 thousandths to 5 and 270 thousandths. Again, that's called a non-essential 0 because it doesn't change the value of the number, but now you have the same number of decimal places, which is 3 decimal places in each case, might make it easier to make the comparison. And then for part D, they want you to go back to B and round each of these to the nearest tenth. So you're going to find your tenths place. You're going to look at your indicator number to the right of that and round it. Same thing here. Tenths place, indicator number, and round it. All right. So that's your homework for section 1.2.3. Thank you.